Our focus standard for today's lesson comes from Grade 7, Number System, Standard 1. Apply and extend previous understandings of addition to add integers. Our topic continues to be from our Adding and Subtracting Integers unit. Rules for Adding Integers, Part 2. Our essential question is, how can we use integer chips to determine the rules when adding integers? Please take a moment pausing the video if you need to copy down the topic and essential question into your header along with today's date. Set your question column and your note column and resume the video when you're ready to begin. So far, in our work with adding integers, we have learned 4 rules for adding integers, and we've done so by using integer chips to look for patterns. So today is part 2 of our rules for adding integers, and we are going to be looking for the last 2 rules when adding integers. So once again, we're going to use the yellow side as our positive integer and the red as our negative integer. We're going to follow the same format as our last video, so go ahead and set up a t-chart. This time we're going to be looking at starting with a negative integer and adding a positive integer to it. And we're going to do 2 sets of problems. So this will be set 3 and then set 4 because we did the first 2 sets in the last video. And once again, I'm going to give you a set of 3 problems to set up with integer chips and then look for a pattern to find the rule. So let's go ahead and start on set 3. Here are the 3 problems that I would like you to write down in your chart and then draw in your integer chips to find the solution. Our first problem in set 3 is negative 8 plus 2. For B, it'll be negative 4 plus 3. And for letter C, it'll be negative 5 plus 1. Go ahead, pausing the video if you need to draw in your integer chips and find your solution, and then resume the video when you're ready to compare your work with mine. Let's see how you did. For your first set, I would expect 8 negative integer chips set up with 2 positive integer chips. We can see that there are 2 zero pairs that cancel out, and we're left with 6 negative integers. So negative 8 plus 2 equals negative 6. For letter B, negative 4 plus 3 would start with negative 4 chips and then 3 positive chips. We'll notice that there are 3 zero pairs that cancel out, leaving us with just 1 negative. So negative 4 plus 3 is negative 1. And for letter C, our last problem in this set, we would have 5 negatives with 1 positive, remembering to cancel out our 1 zero pair. That then leaves us with negative 4 as our chips left. So negative 5 plus 1 equals negative 4. So once again, you want to start noticing what is in common about these 3 problems that I included them all in one set. There's a rule and a pattern that we want to find here. It might help if we compare it to set 4. So let's go ahead and look at those problems. Your first problem in set A is negative 3 plus 8. Letter B will be -2 plus 6, and letter C will be -4 plus 7. Take a moment pausing the video to draw on your integer chips and find your solution, and then resume the video when you're ready to compare your work with mine. Let's see how you did. For this problem in set 4, we're going to start with 3 negative integer chips. Then we would have 8 positive integer chips. We notice that there are 3 0 pairs that cancel out, leaving us with 5 positives. So -3 plus 8 equals 5. In problem B of this set, we would start out with 2 negative chips, add to that 6 positives, cancel out the 2 0 pairs, and notice that we have 4 positives left. So -2 plus 6 is a +4. On our third and final problem of this set, we would have 4 negative chips laid out with 7 positives. Cancel out the 4 0 pairs, and notice that we have 3 positive integers left. So -4 plus 7 equals 3. So now we need to figure out what does each set have in common, and what rule or pattern is it trying to teach us? Can you see it? Remember in our last video we talked about absolute value of the numbers that we were adding. Notice in set 3 all of our answers are negative from -6, -1, and -4. Also, we start with a negative integer that has a greater absolute value than the positive integer that we're adding to it. -8 has a greater absolute value than 2, -4 has a greater absolute value than 3, and -5 has a greater absolute value than 1. And we see that because in each case, the negative integer chips that we started with stick out further than the positive integer chips we're adding to it. So there's your hint. The rule and the pattern for this first set of integer chips problems, for this set 3, is that if we take a negative integer with a greater absolute value and we add a positive integer with a smaller absolute value, the answer will be negative. On set 4, it's just the opposite. All of our answers were +5, +4, and +3. We started with a negative integer once again, but in this case, the negative integer has a smaller absolute value than the positive integer that we added to it. And once again, we can see the positive chips all stick out further. And so there's our hint that tells us that our fourth and final rule when adding integers is that if we start with a negative integer with a smaller absolute value and add a positive integer with a greater absolute value, the answer is going to be positive. So that is going to conclude our video lesson for today. Please make sure that your notes are complete and come ready to do more work with adding integers in class.